Determine the sum to n terms of the following series. Okay, let us begin. So here we have a series 1 squared plus 3 squared plus 5 squared added to all the way up to n terms. So we have total of n terms here. Now to find out the sum, first our task will be to find out the nth term of the given series. So here to find out the nth term, so let's call it Tn. So let Tn be the nth term of the given series. Now how do we find out the nth term? Because this particular series is neither an arithmetic series nor a geometric series, for it does not have any common difference nor does it have any common ratio. So what we'll do, we can try to understand this. So let's say from the first term we have 1 squared, but we only pick up 1. From the second term we have 3 squared, but let's pick up only 3. Then from the third term we pick up 5, and we can immediately observe here that this particular sequence is going to be in arithmetic progression. Now if they're in arithmetic progression, then we can find out its nth term. So we have a equals to 1, d equals to 2. The nth term of this sequence is going to be given by a plus n minus 1 times the common difference d. We're substituting a with 1, d with 2, we're going to get 2n minus 1. So here we can say that since we're considering tn as the nth term, so nth term of the sequence of the series that's given by, take the nth term of the arithmetic progression and then square this value. So this is going to give us the nth term of the series. Now our goal will be to find out the sum of the nth term. So we have sum of tn, where we'll take tk, we'll change the index where k goes from 1 to n. In other words, what we have here is we have to find out the summation of 2k minus 1. So we have to replace this n value with k here, square this, and let the index k run from 1 to n. When we expand this is going to give back the sum. So this is what we need to find out. Now let's expand to k minus 1 whole square. So we have summation k running from 1 to n. We have 4 times k squared minus 4k added to 1. Now what we'll do, we will expand the summation. So that's going to give us summation 4k squared, where k goes from 1 to n, minus summation 4k with k running from 1 to n, added to summation k running from 1 to n, we have 1. Now 4 being a constant, we can pull it out of the summation sign. So we have 4 multiplied to the summation of k squared, where k goes from 1 to n. Similarly, for the second term, we can pull out the constant 4. So we have 4 times the summation, where summation goes from summation with the index k running from 1 to n. We have k added to summation of 1, where k runs from 1 to n. Okay, now let's try to use the value. So what is summation k squared here? So summation of k squared, where k runs from 1 to n. So when we expand this is simply going to be 1 squared plus 2 squared plus 3 squared all the way up to n squared. So this is the sum of the squares of the first n natural numbers. And we already have a standard formula for obtaining the sum. So that's given by n times n plus 1 multiplied to 2n plus 1 whole divided by 6. Okay, so we can use this value. So we have 4 multiplied to n times n plus 1 times 2n plus 1 whole divided by 6 minus 4 multiplied to, now what is summation of k, where k runs from 1 to n? Now this means we have 1 plus 2 plus 3 all the way up to n, and this is the sum of the first n natural numbers. So the standard formula is given by n times n plus 1 over 2. So we can use this. So we have 4 times n multiplied to n plus 1 whole divided by 2 added to. Now summation of 1 simply means that here we have 1. So summation of 1, where k runs from 1 to n. This is simply 1 plus 1 plus 1, and this is going n number of times to n. So we have simply 1 multiplied to n, which gives us n. So summation of 1, where k runs from 1 to n, is simply going to be n. Okay, so this is summation of tn, where summation of tk, where k runs from 1 to n. Now we have 2 times 2, that's 4, 2 times 3, that's 6. We have 2n multiplied to n plus 1, multiplied to 2n plus 1 whole divided by 3 minus we have 2 times 2, that's 4, so we have 2n times n plus 1 added to n. Okay, let's further simplify. We're going to take the common denominator, so that's going to be equals to 3. So we have 2 times n multiplied to n plus 1 times 2n plus 1 minus, so here we have 6 times n plus 1 added to 3n. Fine. So let's expand everything. We're going to get 4n cubed plus 6n squared plus 2n minus 6n squared minus 6n added to 3n whole divided by 3. Now we have positive 6n squared and negative 6n squared cancelling out. So we have 3n plus 2n, so that's 5n. 5n minus 6n, that's simply going to be n. So we have 4n cubed minus n divided by 3. And what we can do, we can take n as the common factor. So we have n times 4n squared minus 1 divided by 3. So this is going to be the summation of tk, where k runs from 1 to n. And in other words, what we have found out, that hence the sum 1 cube plus 3 cube plus 5 cube all the way up to n terms. So this sum comes out to be equals to n over 3 multiplied to 4n squared minus 1.